Hey guys, let's continue. So, up till now, we have been looking at linear PDEs. So, now let's start with non-linear PDE. So, your first step is to write out Charpit's auxiliary equation. Now, this is a very lengthy equation and you have to remember it. So, it's dx divided by del f by del p. So, if f is basically your function, f is equal to 0, this is your equation. So this is the entire equation. It's a very lengthy equation, but you have to remember it because you might need to pair any two of these to get your answer. So to write this a little simply, we'll write it like this. So this is the equation, guys. You might have to combine these two or any two, so make sure to remember the whole equation. As long as you keep practicing, you'll learn the equation automatically. So you'll use this to solve for P and Q. And now the second step is you're gonna write dz as del z by del x times dx plus del z by del y times dy. So dz basically becomes p dx plus q dy, and then you're going to integrate and solve. So now when we are doing these PDs, there are basically some special forms that occur. So there are 4 or 5 and you need to identify which form it is, and that will give you the method you have to use. So the first special form is when you are given a function of only P and Q. So in this scenario, fx is equal to fy is equal to fz becomes 0 because the function is only in P and Q. So you're going to write the Charpit's equation. Dx by fp is equal to dy by fq is equal to dz by pfp plus qfq is equal to dp by 0 is equal to dq by 0. As fx and fy and fz are all 0, so both these denominators become 0. So basically you get dp is equal to 0, so p is equal to a. So now you have the value of p. So what you can do is you can find q in terms of a using this. So So you can just write q is equal to phi of a. So your dz becomes p dx plus q dy. That means dz is a dx plus phi a dy. So when you integrate, you'll get z is equal to ax plus phi a times y plus b. So this is your answer. Let's try one more question. Root p plus root q is equal to 1. So you can write this as root p plus root q minus 1 is equal to 0. So again, this is only in the form of p and q. So fx is equal to fy is equal to fz are all 0. So again, if you write this equation, you'll get dp is equal to 0, which means p is equal to a. Now let's put this back over here. So root a plus root q minus 1 is equal to 0. So root q is equal to 1 minus root a. So that's an a, root a. So q becomes 1 minus root a square. So dz is equal to a dx plus 1 minus root a square dy. Let's integrate. You get z is equal to ax plus 1 minus root a whole square y plus b. This is the answer. So here I have just taken an example where we just wrote it as phi, but in the actual question you can just plug it into the original equation and you'll get q in terms of a. Now let's look at the next special form. Special form 2. This is f of x p q is 0 or f of y p q 0 or f of z p q is 0. That means you have p and q and you have only one variable, x, y or z. They are not all present together. So let's consider this one. Let's take f of x p q as 0. That means f of y will be 0 and f of z will be 0. Now let's modify the auxiliary equation. So you get dx by fp is equal to dy by fq is equal to dz by pfp plus qfq is equal to dp by minus fx is equal to dq by 0. So you can directly write dq is equal to 0, which means q is equal to a. Now again you can find p in terms of a, and again you'll write dz is equal to p dx plus q dy, and then you're gonna replace this phi a dx plus q dy, and then you're gonna integrate. So let's take an example. Under root p plus under root q is equal to x this time. Last time we took this as 1. We'll take as x this time. So if you write this equation, you'll get dq is equal to 0. Remember guys, when you're writing in the exam, make sure you write the entire equation. So you'll get dq is equal to 0, which means q is equal to a. So root p plus root a is equal to x. So root p is x minus root a. So p is x minus root a whole square. Now dz is equal to p dx plus q dy. That means x minus under root a whole square dx plus a dy. So now let's integrate this. So you will get z is equal to x minus root a whole cube by 3 plus ay plus b. So this is the answer. So this was an example of when you had x, p and q. Now let's try one with y, p and q. So when you have a function of y, p and q, that means fx is 0 and fz is 0. So the auxiliary equation becomes dx by fp is equal to dy by fq is equal to dz by pfp plus qfq is equal to dp by 0 is equal to dq by minus fy. So you can see that dp is equal to 0. So you'll write p as a. Now you can find q in terms of a using the equation that you were given in the question like we did before. Then you'll write dz is equal to p dx plus q dy. Replace q with replace p with a and q with phi of a and then integrate. So I'll take an example. Q square is equal to yp4. So we know that p is equal to a. So q square is equal to y a raised to 4. That means q is a square root y. So dz is equal to p dx plus q dy. A dx plus a square root y dy. So now let's integrate this. So z is equal to ax plus a square y raised to 3 by 2 divided by 3 by 2 y plus b. Now let's write this a little correctly. Ax plus 2 by 3 a square y raised to 3 by 2 plus b. This is the answer. So this was an example of p, q and y. Now let's check for p, q and z. So here your fx and fy will be 0. So your auxiliary equation will become dx by fp is equal to dy by fq is equal to dz by pfp plus qfq is equal to dp divided by minus pfz is equal to dq divided by minus qfz. So let me use these two so we can cancel out minus and fz and fz. So you get dp by p is equal to dq by q. So let's integrate this. ln p plus ln a is equal to ln q. I'm writing only one constant because you can have another constant here, but it can be adjusted with this constant. So you do not need to, just write one. So this gives us ln ap is equal to ln q, which gives us q is equal to ap. So you get dz is equal to p dx plus q dy. That means p dx plus ap dy. So if you take p common, you'll get dx plus a dy. So now what we're going to do is we're going to find p in terms of z using the given question or the given equation. So you'll do that, and then you'll write dz by p is equal to dx plus a dy, and then we're going to integrate. So let's take an example. P1 plus q is equal to qz. So we'll use q is equal to ap. So let's write this p1 plus q is equal to apz. Let's cancel the p. So z is equal to 1 plus q divided by a. So let's replace q with ap. So you have p plus pq minus qz is equal to 0. I've just modified this equation. So p plus p into ap minus ap into z is equal to 0. So we can cancel 1p. So you're left with 1 plus ap minus az is equal to 0. So ap is equal to az minus 1. So p is equal to az minus 1 divided by a. So now we have p in terms of z, right? So now we are going to put it in this formula. dz divided by az minus 1 divided by a is equal to integral dx, is equal to dx plus a dy. And now we will add the integration signs. So a dz upon az minus 1 is equal to integral dx plus integral a dy. So this becomes a ln az minus 1 divided by a is equal to x plus ay plus b. So let's cancel these a's. So you get ln az minus 1 minus x minus ay minus b is equal to 0. This is the answer. There are a few more special forms that we will cover in the next lecture. If you have any doubts up till now, leave them in the comment section. Thank you.